Now, today we are going to start a new topic. The name of the topic is circles, and let us first discuss some of the important points which we should know in a circle. So, let us start with the introduction part. Now, the first point which I should know in a circle is center. It is said the midpoint of the circle which is equidistant from all points on the boundary of the circle is called center of the circle. It is denoted by O. So now let us draw one figure having a circle. So the point which is equidistant will be O and A. So here O is called center of the circle. Then second point which is there, that is radius. Now the definition of radius, or the point I should say, from the center O, if we draw a line segment to boundary of a circle, then it is called a radius. It is denoted by R. Now, here in the figure I can say OA is my radius R. Now, then the third thing which we should know is circumference. The boundary of the circle, in other words, perimeter of a circle, is called circumference. It is denoted by capital C. Now, moving forward, the fourth definition says diameter. If 2 points on circumference are joined with a straight line, passing through center, then it is called diameter. It is denoted by D. Also D equal to 2 times radius. Now if I make a line like this, then this is my center O and this is a point A and B touching the circles. So then AB is called diameter. So this distance is my diameter. Then coming to the fifth point, that is chord. If any 2 points on the circle are joined, then it is called a chord. Diameter is the longest chord of the circle. Now, here if I want to show the chord, I can say if I join this point and this point, that is C and D, if I join together, so it is chord. Then, moving ahead, sixth point says arc. Any 2 points on circumference taken on circle is called an arc. Now let us understand this by an example. So suppose if I am drawing a circle and I am taking any 2 points A and B. So this is my B point. So this is my A point, this is my B point. Now, if I draw or if I take this part, AB, the colored part, then it is called an arc of the circle. Now, moving ahead, the seventh point says sector. If any 2 points on the circumference are taken on the circle and joined with center O, then they form a sector. Now, Here, if I want to show the sector, I can say if this is my center O and I join OB and OA. So OB and OA are the radius of the circle. So the shaded part is nothing but my sector. Then eighth point says segment. Two points on circle are joined with chord, then the whole part will be segment. Now, here if I want to show a segment, I can say if this is C point and this is D point. And if I join this with a chord, that is straight line, and this whole part will be my segment. Now next point says lines and circle. So if we see the first figure carefully, so a circle and line are not touching each other. But in the second figure, a circle and a line are touching at one point. So such line is called a tangent. So I can say a line which touches a circle in one point is called a tangent to the circle. Here figure 2, A point is the point where the tangent is meeting the circle. So A point is called point of contact, or the contact point. Now, in the third figure, if you see carefully, the circle is touching to 2 points on the line. So, such a line which touches the circle in 2 points is called a secant. So, I can say a line which touches a circle in 2 points is called a secant. Figure 3. Now, if I talk about tangents, I can have infinite tangents to a circle at different points. But at one point, I can have only one tangent. Now, coming to the next point, that is theorem 10.1, it says the tangent at any point of a circle is perpendicular to the radius through the point of contact. So, if I draw the figure, here suppose this is the circle with center O and I am drawing a line which touches the circle exactly at one point A, and now I am drawing this point A. So I can say the line segment, or if I draw the radius from the center O, so then it will be exactly perpendicular to this line. So this the theorem says. Now this theorem proof is not generally asked as it is a theoretical proof, but let us understand that also. Proof: take a point Q on this I let me call as xy on xy line other than A and join OQ. Now let me take one point OQ. Let me say this is my point Q and I have joined it with a dotted line. The point Q must be outside the circle. Here to note that if Q lies inside the circle xy becomes secant to the circle, because then it will touch the circle at 2 points, so it will be a secant to the circle, not a tangent to the circle. So therefore, I can say that OQ will be greater than OA. As this happens for every point on the line xy other than point A. Thus, OA is the shortest distance between O and A. Therefore, OA is perpendicular to xy. Now next is exercise 10.1 question 1 says how many tangents can a circle have? So the answer is there can be infinite tangents to a circle as a circle is made up of infinite points which are equidistant from a point O which is center. Since there are infinite points on the circumference of the circle, infinite tangents can be drawn to the circle. Now, question 2 says filling the blanks. A tangent to the circle intersect it in dash point or points. So it will be answer will be 1 point. Then second one says a line intersecting a circle in 2 points is called. So this is definition of secant. So the answer will be secant. Then third, a circle can have dash parallel tangents at most. So here the answer will be 2. Then the fourth one says the common point of a tangent to a circle and the circle is called point of contact. So point of contact. Now, third question says a tangent PQ at a point P of a circle of radius 5 centimeter meets a line through the center O at a point Q so that OQ equal to 12. Length PQ is so. See, here I have drawn the diagram and shown the whole situation. Now, I can say in the figure, in the figure, the line that is drawn from the center of a circle to the tangent PQ is perpendicular to PQ. So, therefore, I can say OP is perpendicular to PQ. Now, using Pythagoras theorem, in triangle OPQ, I can say OQ square equal to OP square plus PQ square. So OQ is 12, so 12 square equal to OP is 5, so 5 square plus PQ square. So therefore PQ square will be equal to 12 square minus 5 square. So which will be equal to 144 minus 25. So, therefore, PQ equal to root of 119 centimeter. Now, next question says draw a circle and two lines parallel to a given line such that one is a tangent and the other is a secant to the circle. So, here first I am drawing a circle. Now, to this circle, I am drawing two lines. One should touch the circle in 2 points. So, this is a line which is touching the circle in 2 points, and one line should be such which touches the circle in 1 point. So, that is this line. Now, I am giving them the name. So, here it is touching at A and B point, and I am showing it with an arrow so that it is a line, and this line is touching the circle at C point. So I can say, let me give the name X and Y to this. So I can say AB line is a secant to the circle and XY line will be a tangent to the circle. Things or cases. So first is there is no tangent to a circle passing through a point lying inside the circle. That means if this is the point A lying inside the circle, I can't have any line passing through that which is tangent to the circle. Now, case 2 says there is one and only one tangent to a circle passing through a point lying on the circle. That means in the figure, only A can be one point from which the tangent can pass. There can't be any other point A through which the same tangent can pass. Then case 3 is there are exactly two tangents to a circle through point lying outside the circle. As shown in the figure, P is an external point to the circle with center O, and from there I can have only two tangents A, PA and PB, which are tangents to the circle. Now, theorem 10.2 says the lengths of tangents drawn from an external point to a circle are equal. So, the figure is shown below. P is an external point of the circle with center O and it is touching PA and PB as tangents. I have to prove here that PA equal to PB. That is length of PA equal to length of PB. So proof in triangle POA and triangle POB, angle PAO equal to angle PBO equal to 90 degree. PO is equal to PO, that is common. And OA equal to OB, radius of same circle, radii of same circle. So therefore I can say triangle POA is congruent to triangle POB using RHS rule. So therefore PA equal to PB, CPCT. See, I have proved both the triangles congruent and then all the corresponding parts of corresponding triangle are similar. So that property I have used to prove the theorem. Next, the question says from a point Q, the length of the tangent to a circle is 24 centimeter and the distance of Q from the center is 5 centimeter, 25 centimeter. The radius of the circle is dash. So here, showing the same in the diagrammatic form, I have shown PQ as 24 centimeter, which is a tangent to the circle with center O and radius R, and OQ equal to 25. So I can say in right triangle OPQ, OQ square will be equal to OP square plus PQ square. So OQ is 25. So 25 square equal to OP. OP is R radius. So R square plus PQ. So 24 square. So I can say 625 minus 576, that is 24 square equal to r square. So therefore, r square equal to 49, which is equal to 7 square. So therefore, r equal to 7 centimeter. So therefore, the correct option is option A. Now next question says in the figure, if TP and TQ are the two tangents to a circle with center O so that angle POQ equal to 110 degree, then angle PTQ. So here we can see that POQT is a quadrilateral, and we know that sum of all angles of quadrilateral is 360. So I can say angle P plus angle O plus angle Q plus angle T will be equal to 360 degree. So angle P is 90 degree, angle O is 110 degree, angle Q is 90 degree, and angle T I want to find equal to 360 degree. So angle T will be equal to 360 minus 290. So angle T equal to 70 degree. Therefore, option B is correct. Third question says, if tangents PA and PB from a point to a circle with center O are inclined to each other at an angle of 80 degree. Here angle P is 80 degree, then angle POA is equal to, I have to find. So as you can see in the diagram, I have joined PA and PB are the two tangents, and PO is the central line which is joining P from the center O. And angle A and angle B will be 90, angle P equal to 80 degree. So I can say in triangle POA and triangle POB, angle A equal to angle B equal to 90 degree, because that is the theorem that from the center tangent from the center the shortest distance on the tangent will be 90 degree. So that is 90 degree. PO equal to PO, that is common. Then OA equal to OB, that are radius of the same circle. So therefore triangle PAO congruent to triangle PBO using RHS rule. Therefore, angle POA equal to angle POB, that is 80 by 2. So that will be 40 degree. So now in triangle PAO, angle APO plus angle POA plus angle OAP equal to 180 degree. Sum of three angles of triangle is 180. So I can say 40 plus angle POA plus angle 90 equal to 180. So therefore, angle POA will be equal to 180 minus 130, that is 50 degree. So my correct option will be option A. Now question 4 says, prove that the tangents drawn at the end of a diameter of a circle are parallel. So to prove it, first I have drawn the figure that I have taken a circle with diameter AB and center O, and X and Y line and P and Q line are two lines which are touching at angle A and point B. So First, I can say I need to prove XY parallel to PQ. So proof, I can say angle XAB equal to angle ABQ equal to 90 degree. So reason I can say from center radius to tangent is perpendicular. So also angle YAB equal to angle PBA equal to 90 degree. So therefore I can say XY. Therefore I can say XY is parallel to PQ as alternate interior angles are equal, thus lines are parallel. Now next question says prove that the perpendicular at a point of contact to the tangent to a circle passes through the center. So diagrammatic representation I have shown here where AB is a line passing through center O perpendicular to XY. But I have to prove that it passes through the center. So here I can say radius is perpendicular to tangent and radius will always pass through the center of the circle, and this only I wanted to prove. So hence proved. Now next question says the length of a tangent from a point A at distance 5 centimeter from the center. See, here it is clear that O and A, the gap is 5 centimeter as it is on the straight line OA. From the center of a circle is 4 centimeter and the tangent AB is at the distance of 4 centimeter. So AB will be 4 centimeter. Find the radius of the circle. Now we know that OB is perpendicular to AB. Therefore, in triangle OAB, angle B equal to 90 degree. Now I got angle B equal to 90 degree. So using Pythagoras theorem, OB square plus BA square will be equal to AO square. So OB I don't know, so I am taking it as R square plus BA. BA is 4, so 4 square equal to OA, so that is 5 square. So R square equal to 5 square minus 4 square. So R square will be equal to 25 minus 16. So R square I got as 9. So R square equal to 3 square. So therefore R equal to 3 centimeter. That is equal to AB. So therefore R equal to 3 centimeter equal to OA, OB. Next is two concentric circles of radii 5 centimeter and 3 centimeter. Find the length of the chord of the larger circle which touches the smaller circle. So, as it is said, two circles are concentric. Concentric means with same center. So, I have shown two circles of radius 5 centimeter and 3 centimeter with radius is 5 centimeter. That is OA is 5 and OC is 3 centimeter. And they are touching to the chord of the longer circle. So naturally longer circle is OA circle with radius OA. So AB is a chord to the circle which touches the smaller circle at C point. That is, it is tangent to the circle. Now I can say in right triangle OCD using Pythagoras theorem. OA square equal to OC square plus AC square. So OA is 5, so 5 square equal to OC is 3 square plus AC I don't know, so plus AC square. So AC square will be equal to 5 square minus 3 square. So AC square equal to 25 minus 9. So AC square equal to 16. So AC square equal to 4 square. Therefore, AC equal to 4 centimeter. But I have still got AC and I want AB. So AB equal to AC plus CB. But if I draw again the radius OB from the center to touch B point, it will be the same. So I can say AB or CB will be equal to CA. So I can say AB will be equal to 4 plus 4, that is 8 centimeter. Next question says a quadrilateral ABCD is drawn to circumscribe a circle. Prove that AB plus CD equal to AD plus BC. Circumscribe means the circle will come inside the quadrilateral. So now seeing this, I can say SD equal to DR, SA equal to AP, BQ equal to PB, and CQ equal to CR. The reason for them are tangent. So just now before we saw the theorem 10.2, so using that I got all these four equals. Now adding LHS and RHS, I will have AS plus SD plus BQ plus CQ equal to DR plus AP plus PB plus AS and SD will be equal to AD plus BQ, BQ plus QC will be equal to BC. Same way R plus RC or CR will be DC, EB will be AB. Question says in figure XY and XY dash Y dash are two parallel tangents to a circle with center O and another tangent AB with point of contact C intersecting a XY at A and X dash Y dash at B. Prove that angle AOB. So I have used that property to make my work easier. Now, can I say in triangle AOP and triangle AOC, OA equal to OA, common, OP equal to OC, radius of same circle, and PA equal to AC, tangents from external point from same external point are equal. So therefore, triangle AOP congruent to triangle ADAOC. This is by SSS rule. So therefore, angle 1 equal to angle 2. This will be using CPCT. Similarly, I can say angle 3 will be equal to angle 4 if I take triangle OQB and OCB. So, in triangle COB and triangle BOQ. So, now angle 1 plus angle 2 plus angle 3 plus angle 4 will be 180 because all the four angles are linear pair. But angle 1 equal to angle 2 and angle 3 equal to angle 4. So, can I write therefore 2 times angle 2 plus 2 times angle 3 will be equal to 180 degree. So, 2 I have taken common. So, angle 2 plus angle 3 equal to 180. Therefore, angle 2 plus angle 3 equal to 90 degree. 180 divided by 2 both sides, 2 I have taken common. Now, angle 2 and angle 3 is nothing but angle AOB. So, I proved that angle AOB equal to 90 degree. Now, next question says, prove that the angle between two tangents drawn from an external point to a circle is supplementary to the angle subtended by the line segment joining the point of contact at the center. Now, here he wants to say that angle P and angle O are 180. So, in quadrilateral, PAOB, angle A plus angle P plus angle B plus angle O equal to 360 degree. So, now angle A is 90 degree plus angle P I don't know, angle B is 90 degree, angle O I don't know, equal to 360 degree. So 90 plus 90 will be 180. So I can say angle P plus angle angle O equal to 360 minus 180. So angle P plus angle O equal to 180. So I proved that sum of angle P and angle O is 180. Now next question says, prove that the parallelogram circumscribing a circle is rhombus. So it is clear again that parallelogram means opposite sides are equal and parallel, and it is a circumscribing a circle. That means circle is inside the parallelogram. So here again I can say ds will be equal to dr, as equal to ap, bq equal to pb, and cq equal to cr. This is nothing but tangents from an external point are equal. So tangents from an same external point are equal. So now adding I will have ds plus as plus bq plus cq equal to dr plus ap plus pb plus cr. So I will have dA plus BC equal to CD plus AB. Now, in parallelogram, AB equal to CD and BC equal to AD. Opposite sides of parallelogram are equal. So therefore, I can say 2BC equal to 2AB. So 2 cancel. So therefore, AB equal to BC. Now I have proved that AB and BC are both equal. Therefore, ABCD is a rhombus. Next question says a triangle ABC is drawn to circumscribe a circle of radius 4 centimeter such that the segments BD and DC into which BC is divided by the point of contact D are the lengths 8 centimeter and 6 centimeter respectively. See figure. Find the sides AB and AC. So here I know as shown in the figure I have drawn the all the things already diagram was given but I have constructed I have elongated the centroid or or the radius I have elongated till the opposite sides. So now I can say this I can use two formulas separately. One I will be using Heron's formula and which we have studied in 9th standard and another area of triangle I will be using. So here A, B, C are sides of triangle and S will be equal to A plus B plus C whole upon 2. So Heron's formula said that area of triangle equal to root of S into S minus A into S minus B into S minus C. This was Heron's formula which we studied in 9th standard. So here A equal to AC which is equal to X plus 6. B will be equal to CB, which is equal to 6 plus 8, that is 14, and C will be equal to AB, which is equal to X plus 8. So S, if I find out, so that will be A plus B plus C upon 2. So X plus 6 plus 14 plus X plus 8 whole upon 2. So that will come as 2x plus 28 upon 2. So if I take 2 common, so x plus 14 whole upon 2. So 2 cancel. So finally I will get x plus 14 centimeter. Now area of triangle will be equal to root of s. So s I have got x plus 14. Now in the bracket x plus 14 minus a. So a we have taken as x plus 6. So I am putting it in the bracket so that I can show you the sign, subtraction sign, how the sign changes. Now x plus 14 s minus b. So s will be x plus 14 minus 14. So this I am writing directly. And the third will be x plus 14 minus c or s minus c. So that will be x plus 8. So this I will get as x plus 14 into x plus 14 minus x minus 6. So x cancel. Then second bracket will be x plus 14 minus 14. So minus and plus 14 will get cancelled. And in the third bracket, I will have x plus 14 minus x minus 8. So this will come to x plus 14 in one bracket. I will have 14 minus 6. So that will be 8 into 6 into x. So this will be the remaining part. So I can say 48x into x plus 14 will be the pending thing. Now, area of triangle ABC equal to area of triangle AOC plus area of triangle AOB plus area of triangle BOC. So that will be equal to half into base AC into OE plus half into AB into OF plus half into BC into OD. So this will be equal to half into x plus 6 into 4. So 2 and 4 I am cutting plus half into AB is x plus 8 into again 4 plus half into plus half into 14 into 4. So again I am cutting this 2. So I will get 2 into x plus 6 plus 2 into x plus 8 plus 14 twos are will be 28. So this I will get as 2x plus 12 plus 2x plus 16 plus 28. So if I solve at the end, I will get 4x plus 56. Now, I have got two different equations. One I got a equal to root of 48x into x plus 14. Second, I have got 4x plus 56. So now I am doing like this. K 1 equal to 2 because both are of the same triangle. So I can say 4x plus 56 equal to root of x plus 14 into 48x. Now I am squaring both sides and taking 4 common from the LHS side. Squaring both sides. So I am doing here, I am taken 4 common, x plus 14 whole square equal to, this will be square root of x plus 14 into 48x whole square. So now this will give me 16 into x plus 14 whole square equal to x plus 14 into 48x. So therefore I will have 16 into x plus 14 into x plus 14 equal to x plus 14 into 48x. So I am cancelling from both sides x plus 14, x plus 14. So I got finally 16x plus 224 equal to 48x. So now rearranging them, I will have 224 equal to 48x minus 16x. So 224 equal to 32x. So x will be 224 upon 32. So x I got as 7. So therefore AB will be x plus 8. So that will be 7 plus 8, that is 15 centimeter. And AC equal to x plus 6, which is equal to 7 plus 6, so 13 centimeter. So I got all both the sides which were asked. Now next question says prove that opposite sides of a quadrilateral circumscribing a circle subtend supplementary angles at the center. So the diagram I have drawn that ABCD is a quadrilateral which is circumscribing a circle, and I have joined all the things to bring it to the thing that I have made. I have drawn the angles and I have named them 1 to 8. Now the midpointing also I am naming it as the point of contact I am naming as different things. So now to prove I have to prove that angle AOD plus angle BOC equal to 180 degree, or I can even prove this also, angle DOC plus angle AOB equal to 180. So any out of two, one I have to prove. So in triangle AOE and triangle AOH, AO equal to AO common, OE equal to OH, that are radii of the same circle, and AE equal to AH, tangents from the same external point, are equal. So therefore I can say angle 1 equal to 2. Similarly, angle 3 equal to angle 4, angle 5 equal to angle 6, and angle 7 equal to angle 8. Now adding all the angles, I will have angle 1 plus angle 2 plus angle 3 plus angle 4 plus angle 5 plus angle 6 plus angle 7 plus angle 8 equal to 360 degree, because they are forming circular. So 2 of angle 1, because angle 1 and angle 2 are equal. Then 3 and 4 are equal. So angle 4, 2 times angle 4 plus 2 times angle 5 plus 2 times angle 7 equal to 360. So therefore, if I take 2 common and cut on that side, I will have angle 1 plus angle 4 plus angle 5 plus angle 8. Instead of 7, I am writing 8 equal to 180. So here I am writing again this step. 2, I am taking 2 times angle 1. Angle 3 and 4, I am taking 4. 2 times, I 2 times for 5 and 6. And for 7 and 8, I am taking 8 2 times equal to 360. Now I am taking 2 common from all and directly divide